Okay, it's 2:05. We'll go ahead and get started. People filter in. Remember, you can always scroll back, or of course, these videos will be saved to view later. Okay. Welcome back. I hope everyone's week has been okay. Spent watching The Tiger King or something like that. I dipped my toe in that world starting last night. It's pretty fascinating. Some things that have come up in just talking to some educator friends who are trying to navigate this time teaching sculpture or other kind of foundational classes to young artists was like different CAD packages that are out there, or different free options. Especially is something I'm really interested in talking about. But I wanted to maybe make a case for Fusion because it is particular, and learning this stuff is an investment of time. And you might really be the kind of person who's interested in doing something in a three-dimensional software tool, but maybe you're more interested in animating or building video games, or like digitally sculpting. We've seen that Fusion has a lot of amazing tools built into it, but it's something that I've found has been the best tool for me. It might not be the best tool for you. So I wanted to go over some other options that are out there. First thing I wanted to share was Autodesk Maya. It's also available to students and educators through a very similar license to what Fusion is available for. Autodesk also has another program called 3ds Max that I think they're consolidating into Maya. Someone correct me if I'm wrong on that. But both of those softwares, Maya and 3ds Max, are geared towards 3D animators, people working for Hollywood or special effects, or those who are developing video game characters and environments. It's still an environment where you can, the CAD environment is one where you can build geometry from scratch, from the ground up, using a number of like primitive shapes like spheres, cubes, cylinders, cones, and also push and pull and modify those things into the shapes you need. But it's a different kind of geometry that's unlike the solids that we're working with in Fusion. So if you were working between those two softwares, they can communicate as far as working with the materials they can share, but you're going to lose out on some of the functionality that you could get from Fusion, where you have that parametric modeling, where you can go back into your history or go back into your features and parameters and sketches and rebuild things, and have those changes that you make earlier in the timeline echo throughout. That being said, it's a hugely powerful program, Maya. There's things like physics built into it, where you can like make something look like cloth or like jelly. You can have something blow in the wind. You can have things happen with animation in Maya that you can't do in Fusion. You can animate things in Fusion, but nothing like this. Something very different from what we're looking at in Fusion, and is even different than Maya, is a software like ZBrush. Autodesk also has a program called Mudbox that's also available with a student license, just like Maya and Fusion. But ZBrush is maybe one of the more industry standard software packages for digitally sculpting characters, monsters, things that really require like an organic feel and touch. All the tools in this software are sort of based around working with clay. It's supposed to be kind of analog to that, at least. Of course, there's no like tactile feedback, but it's really cool stuff. It's really beyond my knowledge. I've only kind of jumped into these softwares a couple times, made some messes. It's kind of fun, but really is not like the shape building and geometry that we're using in Fusion or even Maya. Brings me to Blender. Blender is an amazing, kind of gorgeous software that's made and produced by a nonprofit. It's completely free. You can check out their licensing for its uses on their website. Blender's been around for years. It's only getting better and better. They came out with a version recently that has some amazing technology built into it. You can do all the things that you can do in Maya for the most part, but you can also sculpt inside of Blender like you can in ZBrush or Mudbox. You can also do animation. You can do physics simulations to make animations and to modify materials. You can also render inside of Blender in a really cinematic or photographic way with a built-in rendering engine called Cycles. Depending on your computer, you can really make some amazing scenes that almost look like real life, depending on how you've set it up. If you check out YouTube on like a Blender Cycles animation, you might be really blown away that this stuff is doable from a free piece of software. Amazing tool. I know people who use this for everything, building geometry from the ground up, designing functional objects. There are a lot of plugins for it that can have it behave not like Fusion exactly, but have some of those parameters and some of those more mechanical like relationships that we're working with in Fusion. There's SketchUp. It's been around for a while also. It used to be free when it was owned by Google. I believe there's a free version now, but it's owned by a company called Trimble, who I think has certain licensing for different maybe tiers. I know a lot of like interior designers or carpenters, kind of custom fabricators who use this for laying out, like say, like this cafe scene when they're going to do some build out. It's maybe closer to Rhino, if anything. And I'm going to look at Rhino in a second. I used it maybe 8 years ago, and I found there was limitations for me. That was a while ago, so it may have changed, may have improved since then. But I just found like running into a lot of roadblocks with it. I'm not trying to trash SketchUp. I've just had problems with it in the past, and I've also ran into issues with file conversion between working with SketchUp's native format, the SKP, and bringing that into other softwares like Blender or Fusion or Rhino. It can be done, but they've never been like the cutest files after that. So Rhino, it's what I learned CAD on. It's an amazingly powerful tool, and while it's not free with a student license, you can get it immensely reduced in price. And I think there's a new version, Blender 6 now. I've only used it up till 5. I've kind of fallen off Blender, getting into some of these other softwares. But like I said, it's what I learned from. It's the kind of CAD that's maybe more like AutoCAD, like the classic CAD that's been around for decades and decades, in the way that it's kind of a command-based CAD. You type in, say, like, you want to do an extrude, and you type in EX on the keyboard, and it'll come up with this huge list of commands that include extrude or include just the letter EX. And you can kind of learn what the software is capable of in that almost like linguistic way, which when I was learning CAD was really helpful because the vocabulary is kind of part of knowing what's possible. That being said, there are icons that are graphic and kind of give you an idea, kind of like in Fusion, of what the tools do, or any of these programs, what the tools do. There's hopefully helpful icons that help illustrate that in a really concise way. But I just found like exploring through the language was really how I learned Rhino. It's not parametric based design, at least in the basic bare Rhino format. It's direct editing, so when you make a change, it's kind of that way forever after you save the file. Similar to how Maya and Blender work by default, you kind of have to stay organized in a program that's direct editing like Rhino, where you have to have like a series of layers like you might in Photoshop to prevent destructive editing, where you're permanently changing that file or that data. I have a window over here on the right in a program called Grasshopper, which is a plugin for Rhino. I know a lot of architects really love Rhino because Grasshopper is a plugin that unlocks this like amazing geometry based on equations and relationships. You can see it on the right side here. It's like these wires connected to all of these hubs and like little devices that change the output geometry that you get. So you can kind of feed it either like raw data from the real world or just like numbers and equations and relationships like that. So in a way, it is parametric modeling. You could, and I think people have used Grasshopper as a way to kind of set up standards like you'd have in Fusion. Say you want an object that's like, you know, one half of this width is like, you know, related to this other dimension. You can do that in Fusion, but you can also do it, you know, with a way that's like this different graphic representation with these nodes connecting these different operations together in Rhino here on Grasshopper. You see a lot of buildings out in the world, like this curvy shape here that, you know, maybe were even drawn in Grasshopper and Rhino. I kind of joke when I see like these kind of Starchitect skyscrapers or museums that have all these funny curves. It's like, oh, I feel like this was drawn in Grasshopper and they 3D printed it, and then they got the funding and they built the thing, and like now it's like a beautiful building but completely like inhumane to like exist and operate inside of. Anyway, I love Rhino. I think it's a great way to learn stuff. I just wish it was free. I mean, don't we wish everything was free? But yeah, I owe a lot to it. After Rhino, I got into a program called SolidWorks. It is definitely not free. I had an education license at the time when I was learning. I moved to a program like SolidWorks because I found that the relationships I needed between the things I was designing in my projects needed to be more flexible. I needed, if I had to change something by, you know, a slight little tolerance or a little dimension that needed to, you know, have a little bit more room between two things, rather than rebuilding them all from scratch or having to have this kind of breadcrumb trail of information to go back and change this in order to like redo that operation. I could go back and change a dimension in a program like SolidWorks and it would echo and flow through the history. On the left, you see what we kind of have in Fusion, where we have our history timeline panel at the bottom of the screen in Fusion. It's on the left here in SolidWorks. But you also have your solid bodies, surface bodies, and other kinds of information that you would have in your browser in Fusion. So it's really concentrated with all the information on the left side of the screen in SolidWorks. Now, it's a really expensive software because it is an industry standard. I think they do a lot of innovating in SolidWorks, but it's just not very accessible to, you know, folks who want to learn and maybe who want to like do something for profit, but, you know, can't justify spending thousands of dollars on a license. So that brings me back to Fusion. I got into Fusion because it had so many different things built into it, and it was free for me as a hobbyist or educator or student. I was working on so many projects that involved CNC machining and taking a file from one piece of software into another, you know, drawing your design and then taking it into another piece of software to program a cutting tool to manipulate and cut that material was just like really frustrating. When you made a change in the design or you realized something wasn't working in the design, you had to then redo the design, export it, send it back to your CAM software, that software that is computer-aided manufacturing or machining, to then like reprogram it. And it was just exhausting and there were a lot of errors involved. So I found that Fusion having that integrated CAD and CAM built into one package made things like this possible. This is a screenshot of a project I was doing on this machine I had access to at work that I was working on my own project in the middle of the night. And I couldn't really take off the project that we had going for the job. So I wanted to make sure I could squeeze every kind of inch out of that machine's capabilities so that I wouldn't have to take this other stuff apart. But I didn't want to crash into it with this, you know, $100,000, 50 horsepower milling machine. That thing doesn't stop if you tell it to, you know, go somewhere it shouldn't be. So I modeled everything else that we had on the table so that I could kind of sneak in there and do my own project without having to disrupt that. And I could model it in Fusion to the thousandth of an inch where things were in the real world, but also in my CAD software, which would then translate to the CAM software. So here you see the tool pathing of this cutting tool, just so I could make sure it wasn't going to crash into anything. So that's a little bit about the different softwares that I've had experience with. There's more out there, of course, but those are the kind of different, I guess that's a roadmap. You know, if you're interested in building things in the physical world, you know, small components or things that require some kind of mechanical relationships, I really like Fusion. If you are also building things to work in teams where you need to make shop drawings and share, I recommend Fusion for that too. Rhino, I think, is really popular with architects, but I also know jewelry makers and component makers product designers who use Rhino and use it very successfully. Blender is an amazing piece of software that has so many possibilities, and it's just growing all the time, and it's free, which is incredible. And then something like ZBrush or Mudbox for sculpting, a whole new world to me, to be honest. But it's definitely something, if you're interested in having something more analogous to like a ball of clay to play with in 3D space and have like a tablet to kind of interface with, those might be things to look at. And then programs like Maya, if you want to work in computer generated imaging or video game design, that's like the industry standard there to really get in and understand that form of CAD. You can still take just about, I'd say all of these softwares, including SketchUp too, to a state where you could say like 3D print something. They all kind of have the ability to work in geometry that can do that. But when it comes to like cutting things out with a CNC machine or a laser cutter, or if you want like clear drawings for like manufacturing something or working in the wood shop or metal shop, some of the softwares like Rhino, Fusion, SolidWorks, even SketchUp are going to be best for the kind of precision working that making things with your hands when things have to fit together in a certain way is probably best. So here's what I'd like us to try to accomplish today. This is the tub. I've went ahead and made some improvements and additions. But let's go back to where we were and just kind of review where we're at. So I'm going to close our data panel for now. Right now I've got some bodies visible. Let's see, do we have some? Yeah, there we go. Okay, so we've got our canvases and our intersecting body. And last I checked, we were taking this spline, this more organic kind of custom shape. It's not an ellipse, it's this kind of really flexible shape. These splines are like really powerful and kind of beautiful tools. And we were trying our best to get it to match what was in or on the model rather. So I might continue shaping that actually. And what I did here was I changed the opacity of this gray box. This is our body. This is the actual 3D geometry that we're producing. So it's kind of blocking some of this image. We could either make the canvas darker, but this is still going to intersect it. So I'm gonna, right click on that tub body and go down to opacity control. Let's drop it to 50%. So it's still there, we can see it. And now we can also see our canvas at the same time. So I'm gonna try to find where our spline, I'm actually gonna see it. Let's delete this point. And I think, yeah, there we go. That's a little bit more fair curve. The fewer points we have, the kind of more fair your curves end up being. And we'll look at some ways to visualize your curvature control or curvature visualization. So let's look at it from this angle. Might have to zoom in some. And let's, turn around, look at it from this side. Okay, this is a lot actually kind of sharper here. It's kind of got this like shoulder. So that looks more like it. So if we hit finish, I'm going to turn off our canvases. We're just going to review where we're at. I think this is better. We have that automatic draft built in to our feature, that taper, which kind of looks like the bathtub. But what's maybe not correct about this, if we are just trying to go for what is in the model, is, it's not doing it. Let's go to wireframe. Yeah, the sidewalls of this tub really aren't supposed to taper like the front and the back are. So how do we do that in extrude and keep that taper? Well, we can't really control the taper for a couple of sides. So what we need to do is think of another way we can make this cut. And that is going to lead us to a new command called loft. Now, we don't have to start over, not completely at least. I'm going to increase this opacity a little bit more so we don't get confused with what it is. We're going to use this loft command, and if we hover over it, we can see that it creates a transitional shape between two or more sketch profiles or planar faces. So in the demonstration on that image, there's like a square shape that's morphing into this circle profile. And you can see the computer comes up with what comes between. It's kind of interpolating the rest of the shape. So we want that. I think that can be probably right on the ticket for what we're trying to do. I mentioned we don't have to start over. Well, we are going to get rid of this extrude command, but I want to just check out one number first. I'm going to go to Edit Profile. Okay, we've dropped it down 10 inches. So 10 inches from the top, we've cut down. I just want to remember that number. Instead of deleting this, I'm just going to take my playhead as if we were in Premiere or something, like a video editing software, and just click and drag over to the left. Okay, our feature's still there, but it's suppressed. Okay, if we right click on that feature, we can say we can delete it or delete any feature after that history marker. Okay, we can also right click somewhere on the timeline and say roll history marker to here. Okay, I want to have my history marker after that first sketch. We worked pretty hard on this sketch, as I remember, in this tub opening, so I want to keep that. We've done good work there. It looks like it matches the top of the profile. What we care now about is what's going to be on the bottom, or what the floor is going to meet. Okay, so we want to draw our second sketch where that floor is going to end. So the way I'm going to do that is we're going to start off with some new construction geometry. I'm going to make an offset plane. I'm going to click. It's going to ask me for where do I want to put that plane. I'm going to say I'm going to put it on the top of the box, but we don't want it on the top because we already had access to that. We want to drop this construction plane down where the floor of our tub was in the last sketch. I'm going to click OK. Okay. So, we could now draw a sketch on that new plane. And you can see now we have a new sketch. I'm going to go ahead and let me rename it here. I'm going to say tub floor profile. Okay, there's nothing on our sketch. We have it active because we can see the sketch palette over here on the right. So now we have an origin point. It's floating inside of our box there, the center of our plane, the center of this shape. We could, just take a rectangle and say finish sketch. Okay, that might not give us what we want, but let's go ahead and look at it. I'm going to click on the loft command and click on this profile, and then for some reason I can't get that profile. Even though we can see that sketch, both of these sketches are visible, I can't click on that one. So this body is actually blocking. So you could either change your selection filters over here. I think that's a little extra clicky. I'm just going to hide this body. This sketch is still here, so we can click on those two. And look, we already get a preview of what is going to happen. Now that already looks kind of wrong, but let's go ahead and see what it looks like anyway. So right now, the operation that it will default to is a new body, but we want it to cut our tub. So look what happens when we reveal that tub body. If I click on it, it automatically turns into a cut command to get the red. We look inside, that's kind of weird, maybe neat, but not what we want. So I'm going to roll back again, and I'm going to edit our tub floor profile. Okay, I'm keeping this tub opening viewable right now because we're going to use it. So what I'm going to do is I'm just going to take the marquee, select everything, hit delete, because that rectangle is really not working for us. What I want to do now is reference this shape. So what I'm going to do is I'm going to go to Create, Project Include, and click Project, or we could hit P on the keyboard. So what Project does is it's going to take any edge or any sketch entity that's visible, and it's going to drop it and down project it as if it had this kind of perfect shadow that we were going to draw on that plane. Okay, I'm going to make that plane visible so we can maybe visualize this a little better. Okay, so I'm going to click on both of those two profiles and click OK. Okay, what would it look like if we lofted this? Okay, gave us an error. Okay, our loft command is yellow because we lost a profile. So I need to select that and just kind of reconnect some things. Okay, so that looks a lot like an extrude. A loft with two identical, perfectly aligned profiles is going to just be an extrude, whether it's a cut or a new form or whatever. That should make sense as we were looking at how it was functioning. So I'm going to go back to edit this. And now I'm going to change this to, well, let's work on something else. Let's bring our pictures back. So we're going to maybe change what that line actually is, those splines. And let's try to draw that floor maybe a little better. So what I'm thinking about doing is taking this profile, this loop at that base, and going to the offset sketch command. And what we can do then is we can offset an existing piece of geometry with a unit. Okay, we can flip the side it's on. Okay, we know it's going to be somewhat down here. And I'm going to click OK. We've got a problem with this though. This is really the same as now that taper that we gave it. I'm going to make this outside loop construction geometry because we don't want our loft command to pick up on the outside. So I'm going to change that to construction. Now it's a dotted line. If we hit finish, now we get an error on our loft command. We have to kind of reconnect things again. Okay, let's hide some of this noise. Okay, we can see that looks a lot like when we just gave it a taper, an existing taper. So we still got some more work to do. Just want to check one thing. Yeah, I think what maybe our best option forward is rather than using this existing offset, I think we can use our construction geometry, which if we notice, it's fully defined. We can't click and drag on it because it's defined from this projection. So this is going to be a nice kind of foundation we can draw around. Any point when we're in this photo booth workspace, where that's under our environment, photo booth environment, I think that's purple and we're in this view, it means it's projected geometry. So that's just another kind of subtle piece of communication Fusion's giving us. So I'm going to take this, and if we remember our canvases, so we know we want the walls to kind of end up being flat, and then we have some taper in the back, and then some taper here. We don't know what that taper quite is yet. So we want to go ahead and edit that. Now I'm going to actually, something about this sketch is kind of bugging me. We don't need this or that. Actually, let's do this big thing. Okay, sorry, a little obsessive housekeeping there. So we're going to change our bottom profile sketch. So what I want is a spline of some kind to come inside here a little bit for some taper. And then we know we want some taper here. Okay. Actually, yeah, we'll give that an offset. We want some taper all the way around, but not a ton. So I'm going to give that just an inch offset inward. Okay, it automatically gave us a solid line as not construction geometry, but geometry we're going to change. And I think that'll be enough draft for this part of the tub. If we look at the drawing, maybe we go a little bit further. We can change that offset. Sorry, I'm jumping around a little bit. We can change that offset because it gave us a dimension here. I'm going to double click and say 2. And then look back at our canvas. Okay, that looks like it's lining up a little better. Okay, so we're gonna have some slight draft on the walls, and then this back side is what we really care about. So I'm gonna also project our mirror line since we already went to the trouble to establish that. I'm gonna go to create, project, click again. Now when it projected it, it gave us this purple line, which makes sense. I'm gonna hide that tub opening. So there's our purple line. we want to make sure that is not geometry, but construction geometry. So I'm going to make that a dotted line. Okay, because we still want to use the idea of symmetry to make this curve fit nicely and be symmetric. So I'm going to go to Create. Under our sketch, we're modifying that tub floor profile. Sketch, spline, fit point spline. I'm going to click once, I'm going to click twice, and then click OK. Okay, just 2 points. It's pretty much a straight line. If your spline command is still active, because our cursor has that little squiggle and it's asking us to specify the first point, we can just hit Escape on the keyboard. Oh, I forgot to have my keyboard app on. Okay, and now we can play with these whiskers and keep things flowing and being some kind of nice shape. Now what we don't want is for this to happen, for our spline to kind of go outside of our existing geometry. First thing I'm going to do, we know we want this to be perpendicular to our center line here. Let's look at it this way. So remember we can do that. We go over up to constraints. So we're editing our sketch, go to perpendicular. I'm going to select that handle first and then the center line. Okay, that means that when we mirror this, it will flow nicely into that piece. I'm going to hit Escape. And now we might want to play with this handle and kind of see what happens. We might want to shorten this one. The longer we go, the kind of more extreme that curvature is. The shorter it is, the closer to a straight line it's trying to be. Okay, that looks okay. Now over here, what I'm going to try to do is make this spline tangent to this existing spline. So let's see how that goes. So I'm going to go up to constraints. Tangent means it's going to have that curve smoothly transition into an existing curve without like a jagged junction. Click once, click twice. Beautiful. So if we zoom in here, we can see that this spline flows into that shape nicely. Now we added 2 new relationships or constraints, but we can see that our spline is still blue. If we move it, it looks like it's not changing, but we let go, that relationship updates. Looks like it's wrong, we click, it updates. So there's a few more things that we can constrain this with. Okay, it's not going to let me do that until we kind of go past an extreme. We can maybe shorten this. We could elongate it to a certain point. What's going on? Let's try to make this handle tangent. Okay, it's not doing it. Let's just redo that tangent there. Okay. So yeah, this handle can change, and this handle can change, and then our distances. This distance is flexible, just like this distance is flexible along that spline. Here we go, now we're tangent. I'm going to go ahead and mirror this because we know that we've got it nice and set up. So I'm going to make sure I have nothing selected, hit Escape a couple thousand times, click Create, Mirror. I want to make sure we answer the questions in order. We want to select the object first, and then our mirror line second. Make sure we click in that box before we continue, and click OK. Okay, I don't really have the best picture of where that slope for the back needs to come in. We kind of get an idea here. Oh, we've got it backwards, huh? Oh dear. No, that's right. Okay. That's a little strange. Okay, we'll go off this picture then. So we've got some obscuring happening. But what I wanted to look at was maybe an existing drawing of a bathtub. So I've put something in our data panel. I mentioned we can store files in here. So I'm going to open that up, and I've put our reference images in here, and I've also downloaded a little brochure from Kohler. So if I double click on that, or double click on that. There we are. It opened it up in Chrome. Bring it over here to this window. So it put it in our Autodesk 360 folder online in our document. So what I was looking at was there's a couple things about this tub that I'm interested in. We were looking at this angle. So it says 29 degrees from the kind of perpendicular, this back slope. And I'm noticing something else that's going on here. This makes sense. This object is going to hold water. We want to make sure it drains efficiently. So there's a slope to the floor of this bathtub. So we'll keep that in mind. We'll work on this for now, this lumbar angle. So I'm going to tab back over to Fusion. And we're going to go ahead and do Finish Sketch. And then let's go ahead and just open up our loft and reconnect some things. So we've got our top profile. That's good. I'm going to hide that body. Hide that for now. Now we are looking for our second profile. So Fusion has a couple options it's giving us. These are both closed loops, these bottom profiles. And if we hover over them, it's slight, but it kind of glows each of the closed regions. We can select both of them. Okay, and they become one profile, profile 2. We can just select one, and that can be profile 2. Or we can just select this one, and that can become profile 2. So it's with options. We don't have to hold down Control or anything. It's just a continuous click. 1, 2 clicks, that'll make these two profiles. Okay, and it's giving us an error. No target body found to cut or intersect. So it's looking for something to cut because our operation is set to cut. And if we open up objects to cut, there's nothing in that list with this little caret. We open it, nothing happens. So I'm going to go to show that body, and we can see that now an object to cut is revealed, and it's tub body. That's exactly what we want. I'm going to click OK. And everything hid for a second, but we can just bring it back. Sometimes it's a little frustrating why things get hidden at moments. I'm going to leave our tub floor profile sketch on, and I'm going to navigate down to the right plane just by using the view cube there. I'm going to change a few things. We're going to bring this back to 100% opacity, and I'm going to change our visual style to wireframe. Not with hidden edges, just wireframe. Okay. Some things are showing up in this wireframe when we look at it from the right side. We have the far edge of our cutout. And then we have these edges, which for some reason aren't lining up symmetrically. That's a little strange. Okay, so these are called ISO lines, these two lines here. And what we're looking at here is really not a line at all, but just where that feature ends. So that smoothness turns into like a one single tangent point along this curve or along this slope. We wanted to determine a way to make that 39 degrees. I think that was our 29 degrees over here in the Kohler alcove bathtub design. So what I want to do is make a new sketch on this profile that we can use to guide this, to guide where that point lands, the distance between here and here, from the back to here. Okay, so how do we do that? We want to put a sketch in the center of our object. So a couple ways we could do that. We could look at origin, and we know that this plane here is perfectly through the center of our form. Okay, because we started our object on the origin. That's one reason why that's really handy. If we start on the origin, we can still use these work planes later. I'm going to show you another way to do it. If we go to Construct, Midplane, I really like this. It's one of the quickest kind of ways to make a new piece of construction geometry without having to do any math. We can click on, it's kind of noisy, let's make that a little easier to look at. Click on this side, and then this side. Okay, that's the exact same plane that we end up with here as this origin plane. They're coplanar. They're right on top of each other. So it's kind of redundant to do that. But sometimes it's easier and more meaningful to make a new piece of geometry when you know what you want to use it for. So I went ahead and called it midplane. I also like it a lot because it's completely kind of intersecting the shape, and that kind of really speaks to the object rather than that origin, which we care kind of most about the object right now. Okay, so we want to draw a line from the top to that point at 29 degrees. So I'm going to start a new sketch, click on that plane we just made, then I'm going to drop back down to the right, looking at it perfectly in line. I'm going to go to display, wireframe, I'm going to just start to draw that triangle. I'm not going to make it perfect. I'm just going to start drawing it. Just like a scalene triangle, nothing's perfect. If you happen to get this to be 90 degrees to each other, that's cool. But I'm going to define this triangle because right now it could be anything. So there's a little review on constraints. We're going to click on constraints. Perpendicular, we want this to be 90 degrees. We want this part of the triangle to be collinear, meaning sharing this line. So constraints, collinear. Click on the top of that triangle, click on the top, which is really just that edge that we've now projected. See how that turned purple? It automatically projected that edge of the tub into the center. Okay, so that's a lot of our triangle already done. We can still change this to any angle. And then this point can be kind of anywhere in space. So we have two more things we want to do. We want this angle here and here to be 29 degrees if we look at it. So I'm going to go to create, sketch dimension, click on one line, click on this line, make sure we click on both, and then we get this new dimension. It's no longer a linear dimension, it's an angular dimension. I'll show that again. If I go to create, sketch dimension, click on one line, click on the other line, we get this angular dimension. We want that to be 29 degrees. This triangle's still not fully constrained. It can live kind of anywhere. So we need one more piece of the puzzle. Okay, this might be kind of a wacky view to look at. Let's try it this way. Okay, so we can kind of see our triangle inside of the tub now. We want to make sure this point lands somewhere along this line, but we know we want it to be this point here, which, remember, this spline is unconstrained. So I'm going to click on coincident, hover over and find the point of that triangle, and we can go back down and view it this way if we want, but I know that I'm looking for that point there. Okay, now that's constrained. Now here's the problem. This triangle doesn't meet up with this point, because what we actually care about is the angle from this edge to this edge being 29 degrees. So because we based it off of the existing point, this unconstrained area, this isn't quite doing what we want it to do. So how do we undo a constraint? I'm going to click on that point, and if we can't see it because it's really subtle, we can zoom in. I've got that same point selected, and there's two different coincident icons. Okay, it's that coincident icon here. Let's experiment. We can actually click on these and select them. You just want to make sure your cursor is right there. They don't get any bigger as you zoom in. That's one thing just to keep in mind. So click on the piece of geometry you want to change. And let's try that second one. If we hit delete, what happens? Okay, looks like that was the wrong coincident. This triangle came with a coincident point where those two lines met. So I'm going to Control Z a couple times. Okay, click on it, and let's try to delete that one. Okay, notice our triangle went blue again, and it should be free to take off. Something's gone. There we go. Okay, so that point that I was clicking on was the point that was on the existing sketch beneath it. Our triangle is indeed free. So just kind of had to take a breather there. Reset some things. Okay, so how do we make this right? Triangle's unconstrained. This is the point we want to match up here. I'm going to go to Finish Sketch. What we need to do is change the order of some of these features. We can actually drag these things around. I'm going to go ahead and name this so we don't lose it in the kind of chaos that's about to happen. I'm going to double click on it, or you can right click rename, and I'm going to say lumbar angle. We want this sketch to come before our tub floor profile sketch. So let's see if we can do that. I'm going to click on it. Oh, it's not that. That's interesting. Let's go ahead and get rid of some things along the way. Okay, I think I know why. I think somehow we've taken geometry from this sketch and made it rely on this sketch. So notice how it's not letting me move this. I can't drag it, and I can't drag this one anywhere else. So I'll edit this for those watching now. This is what happens sometimes. We get things in the wrong order, but I'll edit this so maybe we can skip ahead and edit that out. We'll go ahead and keep it. So teaching moment. Let's just go ahead and get rid of this. We can make that happen really quickly. Again, actually, let's keep our loft just so we don't confuse everybody in every which way. Keep that mid plane there. Okay, these are open and we want that sketch. We want our mid plane on. So I'm going to create sketch, take our mid plane, and we look down this way, and we know we want a triangle of some sort. So click, 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 click. Perpendicular, we want a right triangle. We want the top to be collinear. And we want this angle to be 29 degrees. Okay, that wasn't so bad to remake, right? Sometimes it's worth it. So now what we want is this point to be coincident with the back of our tub. That's where the back would rest if we were to lean against it. So I'm going to go to Constraints, Coincident, select this point, and then select that point. If it doesn't work the first time, try it again. There we go. Okay, it said it was over constrained, but then we fixed it. Okay, still not a fully constrained sketch because this distance. So this, we know the depth. We know that's going to be 10. Okay, so if we think about the design intent of this tub, we didn't want the triangle to match the floor profile. We wanted the floor profile to match up with the triangle. So now that triangle is a fixed thing. I can't move it around. So it's now that measuring tool that we were really interested in. Now you could, because you know that you're not going to make any cuts or features with this, you could just make this all sketch geometry. So I'm going to select everything and click on construction. And let's rename this. Cool. Sometimes if things go wrong, it's useful. So our tub floor profile sketch is still here. So this is awesome. Let's go ahead and right click, edit sketch. And now we see that this profile is flexible until we make it coincident with that point. And if you just want to see that a different way, maybe it's more confusing. But we want that angle to intersect with that point, or the point on the triangle to intersect with this. So let's have nothing selected, hit escape, go to constraints, coincident. I'm gonna click on the thing we want to move, that point. We can tell that's from the spline because of that control handle, that whisker. Click on the point, click on the tip of the triangle. I'm gonna hit escape. It's constrained now, we can't move that, but we can still change the length of that handle. I want to view this from the top. Okay, sometimes when I click on the view cube, it just kind of takes me out into space. So you might want to get in the habit of just clicking fit. Okay, let's zoom out a little bit so we can see better. So if I raise that, it makes more of a kind of a sharp shoulder. And if I shorten that, it'll make it a little softer. Same down here. If we shorten that, it'll make it more of a straight line. Here we really sharpen that until it becomes concave. So if it's convex, then it's concave. I'm looking up here when I say that. So if you're not getting your handles, if you don't see them, click on the point that you know that handle belongs to. Okay, so it is kind of, let's try that. I'm going to hit finish sketch. Okay, so that looks a lot neater. I want to check one thing. So this sketch, I'm going to close our other two sketches. I'm just going to look at, we're looking at the tub floor profile. I'm going to check out one thing. I'm going to make a new line and just connect these 2 points and make that a construction line. And then I want to measure the angle between this point and our center line, this line and our center line, excuse me. Okay, it's 90 degrees. Very well. We could try another constraint here. Okay, so that would be over constraint, so we don't need that. I was speaking to our issue I was noticing earlier where we had 2 different lines. Okay, so it went ahead and auto-updated our loft. We didn't have to change any of that stuff because we were using that same tub floor profile, even though all of that back and forth, back and forth, back and forth, shifting things around, shuffling things around, it's still connected to our tub floor profile. Very cool. Okay. Now we want to check out one more thing, and then I think I'll give us a break today. We want to make sure this drains towards our drain. We want it to drain that way. So we need some slope in the floor here. Back to wireframe. Yeah, those are still misaligned. That's kind of goofy. That's kind of buggy. So we want this floor to slope downward. So let's write a new piece of construction geometry. I'll leave it like this. I'm going to take that plane, I'm going to call this tub floor. That was that 10 inches down. Maybe we could even annotate that. And I'm going to go to construct plane at angle. Let's do it this way. So we've got this plane, and then we've got our tub floor profile. That line I drew there, I'm actually going to use that as kind of a pivot point. Maybe it's not the most accurate way, but I think it'll work. Oh, no. Better idea, better idea. Let's go ahead and look at that and see why that might not work. So if we go to excuse me. Wow, we're losing it today. Plane at angle. Click on that line. We can make a plane, and then we could put our sketch geometry there. But what's not going to work is we want that geometry to be, everything to be below that 10 inches. We want 10 inches of depth and greater. Because as it stands now, if we see this faint orange line, if we pivot from this part, which is not the final point there, this is going to intersect and we'll end up lowering our depth. We want it to be 10 inches from here and then deeper. So I'm going to hit cancel. Let's make our mid-plane sketch visible. And what I'm going to do this time is go to create sketch, click on our mid-plane, and I'm going to draw a line. Okay, looking at it straight from the side, I just drew kind of a messy line. So what I want that line to do is intersect at that point. This point has been very busy. So we're going to go to constraints, coincident, 1 point and 2 points. There it goes. If it doesn't jump the first time, try the combination again with your coincident cursor active. I'm going to hit escape. And this line is, again, free. So I'm going to make this angle in here. See if we can make that. Let's give that something. So if we click on this center line, okay, that's that center line. And then our slope, let's give that 3 degrees. Maybe that's not perfect plumbing. And now I'm going to make this construction geometry, so I'm going to click on it, click construction. And this is still, this free point could kind of go anywhere. It doesn't really matter that it gets longer here, but what I want it to not do is somehow, because things do kind of change, I don't want it to go this direction because that could cause problems. So I'm going to go ahead and constrain it with a line just to complete this triangle. Okay, so I'm going to make that line. I'm going to make this point coincident with that point, and I'm going to make it perpendicular. So just another 90-degree triangle, just kind of neat. And I'm going to make that construction geometry. Okay, let's go to finish sketch. Okay, there's our angle. Now if we go to plane at angle, we select that line, we get our plane at that angle. Okay, again, I'm going to hide that. I can maybe neaten some things up. Make that construction geometry. Okay. So this is the line that we want to become a plane. So I'm going to construct plane at angle, click that bottom plane, that bottom line rather, to become a plane. And I'm going to click OK. All right. So what we need to do now is we want that slope to be a part of our loft. How do we do that? What I'm going to try is to make a new sketch on this plane, call it 3-degree string. So let's click on that plane, go to create new sketch, and I'm going to take let's take our floor profile. We want to take that loop and project it down there. So I'm going to go create, project include, project. Click on the loops we want, and click OK. start to clean stuff up. Here's our new sketch at that angle. Okay, remember there's so many ways to do the same thing in a program like Fusion. This might not be the most efficient, but it sure is fun. All right, I'm going to hit finish sketch. We want to make sure that it's not construction geometry. We want it to be functional geometry. So I'm going to hit finish sketch. Okay, now it didn't update. Why is that? Our loft is way forward in time, or back in time rather. So let's see if we can drag that ahead of this new sketch. Looks like we can. Okay, so I'm going to go Control Z. We'll look at that again. I can click on this feature and drag it forward after this new sketch that we made. So now I have the chance to double click on that. I'm going to hide all the sketches we don't need, hide our body for now. Okay, right now it's selecting our old profile. We want to undo that. So how do we do that? We can come over here in Profiles and we can click on the X. And now you can either click on the plus or just go ahead and click on the profile we want. Again, it's giving us that error that no bodies are found to intersect, and I'm going to re-show that body. Okay, in wireframe view, that looks like one thing. Let's go ahead and look at it in shaded with visible edges. Okay, how about that? We look at it with hidden edges isn't doing it. Let's go back to wireframe. Okay, there's our tub floor with a little bit of draft. Now it can drain. Maybe it's a bit of an aggressive drain. Any plumbers out there, correct me. We're getting a little bit maybe thin here with our wall thickness, but that's okay. This is going to be cast iron, I believe. Okay, we're going for about an hour. I want to leave you with one more beautification tip. Since we did go to all this trouble to make this kind of as functional and comfortable as possible, we want to get rid of these sharp edges. One thing is the sharp edges are going to be really dangerous. If somehow we could make this tub to be, this really dramatic transition from here to here, that's going to like hurt somebody probably. And down here too, with your feet or your hands, whatever, it's going to be really hard to clean too if you have this sharp edge. So let's soften these out. Now this is normally one of the last things I would do in a model. I wouldn't do it so early in the design. And that's why I'm calling this a treat, because we're going to just cheat a little bit, just so a little bit of encouragement. So we can come back on Friday and start to knock out some of the other features like the faucets, and maybe take a break and do like the soap and the shampoo, get some other commands under our belt. So I'm going to go to Modify. Okay, we've been in the Create drawer a lot. I'm going to go to Modify and go to Fillet. Not necessarily Fillet, although if you said fillet, I would know what you're talking about, a fillet. And we can see over here on the right, a nice picture of the before and after with a fillet. Now, in this family of modifications is a chamfer. It's a lot like a fillet, but instead of this round softened edge, we get an angled bevel. So we want to do fillet, because fillet's going to be kind of a soft, nice to the touch thing. First thing let's do, I'm going to start that command, is I'm going to look at the questions it's asking. So it says edges, faces, features. I like to select edges, faces when I can, but edges more often than not. So let's see if we can select all of the faces that we want to add a fillet. And now we can use this handle, but you got to be careful, because sometimes if you go too far, Fusion kind of freaks out. You can see over the right, we're getting this error that the fillet cannot be made to that requested size. If we look at what we've dragged that arrow to be, it's a 7.5 inch radius fillet, which is pretty massive. Eventually, if we back it off and then come forward, we can see here at 2 inches, this edge and this edge are now overlapping. They're kind of cutting into each other. And it's having trouble solving that. Eventually, these are going to become so great that they're going to just crash into each other and you're going to have no thickness there. So Fusion's not letting us do that. This is why I say Fusion is kind of limits itself to what can be like in the real world. Because if you tried to make something in the other way, it like just wouldn't be geometrically possible. They'd be kind of in two places at once. or sharing the same point where they couldn't. In a program like Rhino, you can often make those fillets kind of do these wacky things where they intersect. So that's one caveat about Fusion, is you kind of have to like limit to what is possible. So there's our fillet. Maybe it's going to be a 1/2 inch. Let's try an inch. Now I don't want this to be so small in between this edge and this edge, this top face. We don't want that to be so narrow. So maybe I'll back it back off. I can type in numbers here too and say 0.5, 1/2 inch. Now because I selected this face, this face, this face, it's blending or creating a transition between this face, and this face. And so we can see they all meet. Okay, at that corner. Also the bottom was included. If I hold down Control, I can see what it looks like before and after. But it's also taking and rounding out this top edge. Because we selected that face, it tries to fillet all connected edges. So this top face has how many edges? 1, 2, 3, 4, and then this loop, 5. So it's filleted all 5 of those, and it's blended it with the others. So what happens if we want fewer faces? If I click on the faces, they're not going away. That's kind of frustrating. What's going on? I wanted less. So I'm going to hold down Control, where we get that before picture, and click on that face. And if we let go of Control, we can see now we're not rounding over that inside loop. Okay, we're still rounding over these edges because it's shared by this face too. So this face has 1, 2, 3, 4 edges. It's going to fill out those. Now I'm actually going to not fill out the bottom. So we look at a tub, it meets kind of square with the floor. I'm going to hold down Control and click on that. Okay, but it's still filleted because it's a shared edge. So I'm going to actually start fresh here. I'm going to hold down Control and deselect everything. Instead of selecting a face, I'm going to select the edges that I want. Now this is a lot slower because I have to select so many more objects, but that's okay. Okay, so now I've got 1, 2, 3, 4, 5, 6. Okay. But now I'm avoiding the bottom edge, and I'm avoiding this lip. So now, if we don't have our unit anymore, we can type in, we know we liked 1/2 inch. That looks pretty nice. And now it's sharp on the bottom. And now we can come back and add a different fillet to this top lip if we want. So I'm going to click OK. And now we have a new feature on our timeline, fillet 1. Let's go to Modify Fillet. And let's see what we can do on this floor. I'm going to just select that loop, or we could select the face. And I actually probably want to give this a really smooth, kind of large fillet if I can get away with it. Sometimes filleting is really processor heavy for the computer to solve. So you might get some hiccups in this filleting if you're grabbing this hand. I've crashed many models from trying to just grab this hand and go for it. So it's sometimes better to start off with numbers that you know work and then working up from there, just typing a little trial and error. And it gives you a chance to kind of feel out some samples. Let's go for that. Let's see if it works on the top edge. Okay, now we knew it was going to cut into that other fillet because we saw before when it was so large. Okay, sure enough, kind of bogging down here. Okay, we see that. It was like, that was a close call, even on this computer. I'm going to hold down Control, and I'm going to deselect that top edge. Okay, I think I'm actually going to give this top edge the same radius as these edges. So I'm going to go back, right click, edit this feature. I'm going to hold down Control and add that top edge. Okay, now one last thing, and then for sure, we'll call it a day. I'm going to change this appearance and make this into a material that's going to help us understand more about what it is. Sometimes this is just a simple color coding, like you have an assembly of many parts, and they all kind of blend together in your eyes, in the viewport. So maybe you make one thing blue, you make one thing red, yellow, green, etc. Doesn't necessarily correspond to the material it's supposed to be in the real world when you were to manufacture this thing, but it's just like a visual guide. I like to do kind of both. as I'm working, if I can. So I'm going to go to Modify, Appearance. Okay, you see here by default we have in this design is the steel satin material. This is the steel satin material. It's gray and it has a little bit of reflection. It's a pretty easy to see surface. It picks up a lot of things. But here we have some other materials in our Fusion library. It comes with a lot of different things. Sometimes you can type in, is there ceramic? Okay, no results found. Is there porcelain? Okay, looks like there's not. So let's find something that looks similar. So I'm going to go to plastic. We know that that painted or that enamel cast iron kind of looks kind of like a plastic here, is soft. I'm going to go to opaque plastics, and there's a plastic glossy white. I'm just clicking and dragging it onto the object. I could change that to red, change it to green, change it back to white. And notice it's adding all these materials up here. Even if they're not in the design, they're going to show up in this kind of storage. Okay, so there's now our shiny white tub. If I hit close, we can explore that a little more. It looks very nice. If we go to render, changing workspace, we can see that also shows up in the render viewport. Now this is just a preview render. We can talk more about this later, but this kind of basic render workspace is not so resource heavy. It's not actually making a photorealistic view of what your object's going to be. There's other ways to do that. So if you're not impressed by this render viewport, we can get into this when we get further along in our project. Okay, I'm going to go back to design, and I'm going to save this. So today we went to a lot of trouble to find kind of the right profile. Let's see how that even looks compared to our shape. That looks pretty great, I think. We've got this nice shoulder here. We've got a slope moving down. We've kept these walls pretty straight where they need to be, and there's a nice slope now on the back side for our back support, our lumbar support, if you will. All right, I think we're going to do another session Friday. Folks, please reach out on Instagram or email me, or if you got my number, text me, whatever. If this time is working, 2 p.m., I think, for folks who are in places further east of here, who it's becoming a late night for these things. Let me know how 2 p.m. works. Again, these things are stored on YouTube. I'm going to try to get those uploaded the night of that we put them out. But if you can be here in person live and ask questions, that's awesome. It looks like some more people are jumping in. But I think I'm going to call it for the day. The lofting was a big adventure. I think there's a lot to explore and try out on your own, in your own projects. You can have more than 2 profiles. It's just one thing I want us to remember. We're going to explore that next time as we look at our faucets. Okay. So thank you guys. Be well. I will talk to you on Friday.